Are you an artist who hates wearing headphones while recording? Or a recording engineer who's dealing with headphone-free vocal tracking? Bleed and phase issues can be an absolute nightmare. In today's video, I'm going to show you how to get over all that. What's up everybody? EJ here, and before we dive into today's video, I want to shout out viewer Kulisek, who commented on our last video about different EQ curves to mimic referencing environments. Thank you so much for your view. Thank you so much for your insight, and I will absolutely be getting to videos on how to properly mix low end and also mixing techniques for different genres of music. Today it's all about bleed, and we're talking about bleed from speakers or headphone bleed and how to deal with it. So sometimes as a recording engineer, we might have an artist who's struggling to get that perfect take, and the headphones might be something that's in the way for them. And even though we might try different calibrations or different level balances in the headphones, it's still not right, and the artist does not feel comfortable performing with headphones on. So what do? Well, I heard a quote once that there are no solutions, only trade-offs. So in this situation, we have to move to headphone-free tracking. And in today's video, I'm going to show you a demonstration on how we can minimize bleed in the room. And that's mainly going to revolve around using one speaker, our proximity to that speaker, and the polar pattern on our microphone, and positioning the null, which is the rejection spot, in line with the speaker to have the most amount of cancellation. So what do you say we hop inside the video and see what comes up? So there's a couple things that we have to do to try to limit any sort of comb filtering or phase related issues. And the first thing I would recommend is shutting off one speaker so that the volume and the playback is only coming from the right speaker. The next thing we want to look at would be the overall playback volume. And with that, we want to think about having it the softest we can in order to elicit the performance that we need. So if we really have a lot of extra volume bleeding out into the room, it is going to increase the likelihood of potential comb filtering or phasing. So step one is we're just coming through one speaker. Step two is we set a volume that makes sense. Now the first thing I'm going to do is I'm going to mute the speaker, and I'm going to put on a pair of headphones, standard kind of tracking headphones, pair of Audio-Technicas, and I'm going to stand in front of the mic, which currently is in cardioid, and we're just going to see the level of headphone bleed, which we all know is going to be very, very minimal unless we have these headphones at an insanely loud volume. Or if the music itself is really, really soft and delicate music and we have like a click track or something that's punching through the headphones, that could be problematic. But for the most part, headphone bleed is not typically an issue for standard levels and things like that. So I'm going to do that first. I'm going to put the headphones on and I'm going to record a little sample. This is me testing the microphone. Our next baseline test is going to be the next most common way to work with headphones, which is one ear on and one ear off. I'm going to place the off ear behind my head, which should reduce bleed. I'm talking into the microphone, wearing one headphone. Our next method is if we have an artist who really does not want to wear headphones. And we, as our job as recording engineers, we want to make sure that we put the artist in the best position to succeed, so we're trying to come up with creative solutions. Now this room has some basic sound treatment, but not nearly enough treatment to where I would feel comfortable with the phasing and comb filtering effects of the sound kind of bouncing off the wall and creating issues with reaching back into the microphone and having some destructive frequencies that would blend in with the previously recorded music that is now all commingling in the session. Essentially the bleed from the tracks hitting the room, having some phase-related issues, and then those phase-related issues causing some destructive null spots in our music when the vocal with that bleed is merged with the original tracks. So to try to reduce that, we're going to try the first option, which is still having the mic in cardioid, but we're going to work with the null. Now the null is the spot of the microphone that has the least that has the most amount of rejection from sound coming in the opposite direction. So in a cardioid pattern where it's picking up like this, the null is essentially right behind it. So what we're going to do is we're going to take the microphone and we're going to look at the angle that the speaker is coming at. And I'm going to try to have the microphone in a spot where we're going to look for the most amount of rejection. We're not going to get super crazy, super technical at the moment. We're going to essentially have it in line with one single speaker, relatively close, so that we're not super far back, bringing in a lot of possible additional reflections. And we're going to do this without any treatment, without any sound barrier here, or without any treatment behind me, which would only help to improve what we were talking about. If we were able to have some deadening material like drapes or a mattress or something, anything with insulation that was behind, killing some of the reflections coming back into the microphone, that would be positive. So we're going to work with this in essentially its most bare bones form so we can hear the sound at what we would consider to be the least treated or its worst. This is me standing in front of the microphone. The last option is working with a microphone that has a figure 8 pattern. Now, figure 8 pattern picks up in front of the mic and behind the mic and offers null or rejection points on the sides of the mic. So in this situation, what we're going to do is we're going to turn the mic so that the side is facing towards the speaker. And this is just eyeballing. If we were looking to get really technical, we could record some options of moving the microphone while the music is playing and see if we get an even greater rejection spot. But for the interest of showing the general premise and idea, we're just going to eyeball the first one and look to put it right here in what I would assume to be a solid null spot. Now, when the music is playing, we're playing at about 60 to 65 decibels in the room. So that's a healthy amount. It's not loud by any stretch, but I can hear both myself and the track. And when we're talking about solutions like this, there are no perfect solutions. There's only trade-offs. And if wearing headphones is going to impact the quality of the performance, and the only thing that can bring the performance to the standard it needs for the track to work, then we have to find solutions. And those solutions come with trade-offs. Understand that there will be some bleed, but how do we work with that bleed? And we're going to find out now by switching the mic into figure 8. I'm standing in front of the microphone in figure 8 pattern. Okay, so now we're going to hop inside the DAW. We're going to look at the way our experiment turned out, and we're going to see if there's other tools that exist inside the DAW that might be able to further assist with managing that bleed. Okay, so now that we're inside the DAW, we can take a look at what our results are. One thing I should have mentioned when we were doing the tracking component is you want to have your system on the lowest amount of latency possible. So I jump into Pro Tools when I was tracking and I had it at 64 samples. The more latency we introduce into the playback, the more potential phase issues that we also introduce. So having the sound be as real-time as possible and hitting the mic to create the least amount of latency is going to make sure that we're doing the best we can to retain some phase consistency. But now, since we're not in the recording phase anymore, I'm going to alter that. Okay. So first, we had our headphone baseline test, which I'm going to solo, and we can listen for the level of bleed. I'm speaking into the microphone, wearing headphones, and this is a baseline test of headphone bleed. So if we go to this spot here where the music is playing, we can hear there's minimal bleed with headphones. We can hear some, but standard and nothing that is going to create any issues at all for us when it comes time to mixing. And really where the issues would be is if we started to, say, compress the vocals, to all hell, which is going to draw out all that background noise, or maybe do any kind of wild EQ moves or something that the processing of the track and the impact on even the bleed in the track is going to add something destructive when it folds in to the rest of the multi-tracks. So here is our second test, and this was with one earphone on. I'm talking into the microphone, wearing one headphone. This is a baseline check. of headphone bleed with only one headphone on. So the headphones, we can all agree, have very minimal amounts of bleed. I was listening at around 75 dB in terms of the amount of volume hitting the headphones, and I'd consider that to be a solid amount of level. I've had artists that have pushed a lot more volume in, and some that have asked to have the headphones at a lower volume than that. So I think the most important thing is really the information that's coming through the headphones and the overall dynamic range of the track that we're recording over. So if it was an acoustic guitar and a violin, and I'm tracking vocals and have a click track, slapping through, that might be picked up more than if I was singing over a dense rock track and had the click track up a good amount, which might get lost in, all the other noise being made. So now let's move to the first in the room experiment, meaning no headphones, and that is the cardioid. So we're going to solo that first, and we're going to listen. This is me standing in front of the microphone in cardioid position, doing a baseline check of bleed. Standing in front of the microphone in cardioid with the null pointing right at the speaker. Okay, so more bleed than the others, but still not insane. So let's duplicate this track. Going to solo both. I'm going to pop an EQ on the second one and flip the phase. And let's see how good our phase is here. Okay, everything completely canceled out, which we would expect. Now I'm going to mute our test here, and I'm just going to take this for the interest of time up to here, and let's go with the track now. So we're going to hear the vocal and the track together, and then I'm going to actually play with the phase button and the low pass and see if we notice anything that might have changed. So I'm just going to kind of set a little loop here. And the reason I selected this track is because of the information in it. Horns that have a lot of cut, a lot of harmonic information, very dynamic in terms of the way the track moves. And we have an organ, we have guitar, we have drums, we have horns. So things that are definitely going to kind of cut through and fight the vocal for a little bit of its attention and clarity, and definitely could create some destructive phase relationships if we do not have good phase alignment. So here we go. This is me standing in front of the microphone in cardioid position, doing a baseline check of bleed. Standing in front of the microphone in cardioid with the null pointing right at the speaker. This is me standing in front of the microphone cardioid position. So I like it with our regular phase alignment. When we flipped the phase, I was listening for the snare drum and then the top end, and they seemed to thin out just a smidge. I wasn't really hearing any washiness, and I would encourage everyone, if you're hearing things differently, please drop some notes in the comments below. But if we listen to the track first with this muted, now we'll pop in the vocal. This is me standing in front of the microphone in cardioid position, doing a baseline check of bleed. Standing in front of the microphone in cardioid with the null pointing right at the speaker. So in this situation, I feel that we have a good working vocal track. We do have a little more bleed than our headphones, but nothing destructive. Let's now move to the figure 8. We're going to mute the main track first. I'm standing in front of the microphone in figure 8 pattern, and we are testing for bleed. The side of the microphone is facing towards the speaker, which should allow for the most amount of rejection. All right, so let's listen to this section from the cardioid. And jump down here, and let's listen to this section of the figure 8. So pretty similar. I don't have a reader out to say for certain who's exactly lower, but pretty consistent. And again, the amount of bleed is pretty minimal when we're thinking about all the potential consequences of doing something like this. Right now, we've created a situation where we have a vocal with a little bit of bleed, but nothing that would be a deal breaker as far as being able to use this in a track. So let's go up to the track now and pop it on, and I'm gonna move this off to start, and we'll play with the phase and we'll see what happens with our figure 8 pattern now. So now we're listening to figure 8, which has a rejection on the sides, blended in with the track. And I'm gonna boost the volume up a little. I'm standing in front of the microphone in figure 8 pattern, and we are testing for bleed. The side of the microphone is facing towards the speaker, which should allow for the most amount of rejection. I'm standing in front of the microphone in figure 8 pattern, and we are testing for bleed. The side of the microphone is facing towards the speaker, which should allow for the most amount of rejection. So again, in this situation, I like our phase alignment and didn't feel like I was gaining anything positive by flipping the phase. So what we did here was just kind of remove some of the rumble and get to the area that would be the vocal and the low end or room rumble out of the track. So I think that that's a huge win. Now, how can we enhance this even more? Let's go to the cardioid, and we'll just kind of use the cardioid as our example, and we'll shorten our loop. We can pop on a basic plugin like Clarity by Waves, and we'll just go with the standard. We'll go broad. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. So, other than me driving you crazy by hearing me standing in front of a microphone, we can see that it kind of tightens it up a little bit. We lose a little bit of the bleed, especially in the areas where there is no vocal. And even when we do have the vocal in, it kind of pushes the noise to the back a little bit more. Not that I even really felt it was a problem to begin with. I've absolutely mixed tracks that had more bleeding into the vocal mic than where we started from. So we had a great baseline, and now we're able to use resources to continue to improve and not even have to solve major issues. So now let's just say that it's a super dense track and it's going to require a lot of vocal compression, which would be the biggest enemy of trying to tame the background noise. So we're going to go super extreme, and we'll just grab an 1176. We'll go all buttons in, super fast release, and just get things super spitty. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. This is me standing in front of the microphone. All right, I can't listen to myself anymore. However, I feel that given the fact that we're talking about there being no true solutions, only trade-offs, if we have an artist who is really, really struggling, or if you're the artist that's really struggling wearing headphones, this is a very viable solution. We have to, again, take into account making sure that we properly align the microphone into the rejection spot of the speaker, that we're not engaging the room nodes too much by really blasting the volume out into the room. And these are some tricks once we get into the DAW that we can do to increase the clarity and reduce the bleed of the vocal. But where we kind of left off with both the cardioid and the figure 8, we have a very, very usable vocal outside of me repeating the same thing 30 times. So if I just even copy these down to the figure 8, listen to figure 8. I'm standing in front of the microphone in figure 8 pattern, and we are testing for bleed. I'm standing in front of the microphone in figure 8 pattern, and we are testing for bleed. Again, I like it in the phase alignment that we had, not flipping the phase. But let me know in the comments below what you think. If you had a preference between the cardioid or the figure 8, if you have some tips and tricks that you can share with me on how you would handle a situation where we had to track vocals and the artist did not want to wear headphones. Really appreciate you all watching and look forward to hearing from you. Okay, so I hope you found that video useful. Let me know in the comments below if you have any insight or methods or techniques that you use when you have an artist that requests headphone-free tracking. As always, thank you so much for watching, and please like and subscribe. Have a great day.